install the sensor and collect the data. But no, I mean, the company said like, oh yeah, you have occupancy sensor. This is your temperature sensor. Pay for SaaS and then you can access the data through API. Personally, I didn't want to do that. Okay. So then what's the solution for all of this? Okay, like how do you make sense of all these protocols? Okay, which is not the common IT protocol. If you work in software, you would understand REST APIs. They are common. JSON is common in software industry. But hardware is a different ballgame. Next. So there is a solution for it. Okay, which we call IoT platforms. It's Internet of Things platform. If you have IoT sensors, then you cannot ignore IoT platform. What it does is, it takes all those sensors, meters, and smart devices, which could be any of these protocols. So there is a data transfer protocol, like how the actual data is transferred. Then there is a like communication layer on top of it. So if Modbus devices, like most of the smart meters are Modbus, which is a register-based data transfer protocol. But that's a data protocol. On top of it, how the data is transmitted is a different protocol. So Modbus is transmitted over Ethernet. BACnet, okay, is mostly over Bluetooth. Then you have OPC UA. Okay. All of it can be fed to an IoT platform, and then it transforms the data into the commonly understood protocol, which software teams can understand. Okay, which even a normal person can understand. So think of IoT platform as Google Translator. People are speaking different languages, and now with the help of Google Translator, it's so easy to like convert from one language to another. Oh yeah, you are speaking Hindi, like I speak Hindi. You can go convert it into English or English to Spanish, right? So IoT platforms are like that. I used to travel a lot to Mexico, okay, and people would think that like I could speak Spanish, okay, and I mean I had hard time communicating with the business owners there because I used to travel for business there, and Google Translator was my go-to. I mean I would speak in English, it would convert it into Spanish, and I'm able to communicate with them. I mean one sentence I still know, no entiendo español. That's the only thing I learned 2 years I traveled to Mexico. But anyways, I should have learned that. Okay, next. Then there is a concept of edge computing, okay. I talked about like SaaS software, okay, like collect the data from hardware, now you can take that data over to cloud. Okay, everybody is aware of cloud computing. What cloud computing is? Going back about 20 years ago when I started my career, like at that time cloud was coming, like many people didn't know what cloud is. And I saw a funny thing, like somebody was mentioning, like cloud computing is basically like the data is transmitted from the real cloud. So if there are clouds, your system will work. If there is no cloud, it will not work. So edge computing. Now let's talk about edge. Cloud computing was 20 years ago, but now people are moving more and more towards cloud computing. More and more towards edge computing. What's edge? Anyone here?
Fiber to the farm, baby.
What?
Fiber to the farm. Edge computing is being able to distribute and have a diversified approach to cloud versus being in a co-located methodology. It's at the point of compute, at the point of storage.
At the point of storage, right? So, this is another implementation of on-premise. first of all, on-premise was popular, then cloud became popular, now on-premise is coming back. There is one reason for that, like cost. Many companies quickly move to cloud computing because it can scale very well. But if you have no need to scale, if you have a very local use case, in that case, edge computing is the way to go. I mean, companies, I used to work for like Sunrun, they were paying like, for all their cloud infrastructure, they were paying the amount equivalent to like GDP of Zimbabwe, okay, for example. Okay, and I mean, that's the shock people, companies get or individuals get when they see the bill of like Amazon ECS. So edge computing, what it does is, it's able to collect the data near to the devices. So IoT sensors, in this building, there are sensors. Why send the data over to cloud when you can have an edge computer and implement an IoT platform and store all the data on premise, and then only send the relevant data to the cloud. All these IoT sensors collect the data every 10 seconds, like, or 5 seconds. If all of that data is collected and sent over to the cloud every 10 seconds, I mean, you would go back, really. I mean, companies pay so much. That's where the edge computing and IoT platform come into picture. So there are multiple reasons. So like, look at this Internet of Things. You can process the data on the edge, take the decisions on the edge, and then send only the relevant data to the cloud if people in other locations also need access to the data. In that case, you can go for edge computing. Improve security and privacy. There are a lot of hacks going on, especially on the IoT devices. Edge computing is one way to solve it. Okay, secure your own network, don't expose the data. Increase reliability. Even if the internet goes down, your building is still running. All the systems are running. Reduce latency and bandwidth savings. Would be like some other advantages. Next, please. Okay. Other example of use cases. Can you think of other example of use of edge computing? I mean, these are some common use cases. Roombas, smart vacuums. Okay, like think about Roomba. Roomba is a smart machine. It has got multiple sensors. It can detect the fall. All of it is being done on the edge, like on the device itself. It's able to collect all the data from its sensors and able to say whether like, it's the stairs or not. It's not sending the data over to the cloud. I mean, think about if this is all being done on the cloud, what would happen? Roomba would collect the data from the sensors that, yeah, stairs is coming, it will send it to the cloud, and then models are running on the cloud to say, yeah, it's a stair, now send the data. By that time, Roomba has fallen down the stairs. There could be some delay between the data collected to data processed. Because of the edge computing, this doesn't happen. It's fast. Collect the data, take the decision. Smart cars. And also in the agriculture where there is no internet available, you could do self-driving. Okay. Next. Okay, so now let's go to the case study. Okay. So we talked about what IoT is, what edge computing is, why edge computing versus cloud computing. So this is the project that we did for PAE. It's a smart building. They are living